Hello, this is Bud Frable from Midpoint Bearing. This is my first webinar, and I decided to start from the basics. Today's presentation, Bearing Basics Part 1, is designed for the beginner. My goal for this presentation is to last approximately 30 minutes. The topics covered in this presentation are a quick overview of midpoint bearing, a little about myself. I believe it's important to know a little bit about the person presenting. Then I will discuss components and types of ball and roller bearings with a focus on electric motor repair and pump repair. To break it up, I will take a moment and we'll go over some key terminology, load, speeds, point, line, contact, that type of stuff. And then we will finish her up with a little wrap up and my contact information. Midpoint Bearing Overview. Midpoint Bearing was established in 1985. We are a distributor of bearings and power transmission products. We have 4 locations: California, Texas, Oklahoma, and Indiana. Our California location is where our corporate headquarters is located. Midpoint Bearing specializes in bearings for 4 specific industries: the wind turbine repair, the electric motor repair industry, steel mill equipment, and the pump repair industry. Midpoint Bearing is a factory authorized distributor for SKF, Koyo, NTN, Schaeffler, Nachi, Timken, and other products that support the electric motor industry, such as Aegis grounding rings, CR seals, Benchmark thermal, US seal, and many more. Another key point about Midpoint Bearing is that we do not sell motors. Bud's background. So I am born and raised in a small town called Napoleon, Ohio. I left there to serve in the U.S. Army, active duty for 5 years. I was in North Carolina at Fort Bragg and the Republic of Panama. Got out of the military and I became a steel rule die builder. During the latter years of that career, I started college and finished my mechanical engineering degree at Cleveland State University. And then I spent 13 years at Koyo Bearing in the engineering department. And in 2012, I was given the opportunity to work for Midpoint Bearing. With Midpoint Bearing, I wear a few hats. My major hats are sales for the Midwest, and I am their corporate engineer, handle all engineering stuff for the entire country. Our first topic that we will cover today is ball bearings. I will focus on electric motor repair and pump repair, the types and components. I felt it was important to first define what a bearing is. A bearing is a highly engineered piece of machinery. It's a component that allows parts to move, slide, or rotate. These are found in almost every type of machinery. There are 2 general categories of bearings. Number 1 are sliding surface bearings. These consist of your plain bearings or your journal bearings and your rolling contact bearings, such as your ball bearings, your roller bearings that we will be discussing in this presentation. 3 major functions of bearings. Number 1 is to carry load. Number 2 is to reduce friction. And number 3 is to position moving parts within the assembly. Now we'll move on and discuss ball bearings. Our first major type of bearing is one of the most common bearings in the world. It is called a deep groove ball bearing, also called a Conrad. This bearing is designed for moderately heavy loads with the ability to carry some slight axial loading. The components of this bearing are the outer ring, the rolling element, which in this case is a ball, the cage, sometimes referred to as a retainer or a separator, These terms all define what the cage is doing. It cages that rolling element to keep it in its position. It retains it in that location, and it separates the rolling elements from each other. The other component is the inner ring. In many cases, people will refer to the inner ring and the outer ring as the bearing races. The true raceway in a bearing is the curved surfaces where the rolling elements will contact the rings. There's many variations of the deep groove ball bearing. They can be employed with shields on both sides, such as the picture shown here. They can have seals on both sides. You may also have a max type or filling slot style bearing, a bearing with a snap ring groove and snap ring, and insulated bearings. There's many different ways to insulate, with coatings along the contact areas on the outer ring or the inner ring to the journal or the housing, or using silicone nitride for the rolling elements. Our next major ball bearing is the angular contact ball bearing. Its components are the same as the deep groove ball bearing. Consist of an outer ring, an inner ring, rolling elements, in this case is a ball, and the cage, retainer, or separator. This picture is showing it with a bronze style retainer. The angular contact bearing is designed with higher shoulders on both the inner and the outer ring positioned opposite of each other. This design allows for the bearing to handle both radial and axial load. This contact angle can be increased to allow for higher axial loading capabilities. As you can see, the shoulder on the outer ring here is higher, and the shoulder here on the inner ring is higher, creating this contact angle, as you see here. And as you make this angle larger, the more axial load this bearing can handle. The most common seen in the aftermarket is the B designation for 40-degree contact angle. You also can see in the industry is a C, which is a 15-degree contact angle. The A is also out there, but a lot of times you won't notice the A because it's omitted in a lot of nomenclature. So if there is not a letter associated with your part number, it is most commonly going to be an A, or a 30-degree contact angle. Continuing with the angular contact ball bearing, there is also a matched pair angular contact bearing common arrangements that I'd like to discuss. Angular contacts are often used in sets that allow for higher axial loading capabilities, or to give you the ability to have both direction axial load support. What we'll see here on this first one is a DT, or a tandem design. If a single bearing does not have enough capacity load-wise, you can stack angular contacts to increase the amount of axial load. It is not a direct, if bearing A can carry 100 pounds of load, if you put 2, it's 200 pounds. It's actually load rating times the number of bearings to the power of 0.7. So 2 bearings would be 162 pounds over the 200 pounds that you would naturally think if you just added the two together. The next common one is a back-to-back arrangement. In this case, as you can see from our image here, our angles are going away from each other. And what this does is it builds a more rigid system. This also is allowing load to be carried in both directions. The last one shown on the screen is a face-to-face arrangement. In this case, you'll see that the contact angles are crossing each other. This allows for a slight amount of misalignment. Also, because they are facing opposite directions, this design can also carry load in both directions. I do like to look at the contact angles like table legs to help you understand which one can handle misalignment and which one is rigid. If your table has legs that are going away from each other, such as the back-to-back arrangement, you will have a rigid or very stable table. If your table had legs that were crossing, your table might wobble. To me, that's just a very simple way of getting an understanding of, is this a back-to-back arrangement or is this a face-to-face arrangement? There are many more common types of ball bearings. On the screen in front of you, you'll see the thrust bearing. This style of bearing, the rings are often called washers. The two rings are parallel to each other with the rolling element and cages in between. This design is set to carry mainly an axial load. The next design is a self-aligning ball bearing. This bearing has also been referred to as the spherical raced ball bearing because of the design of the outer ring. This particular bearing is very similar to the deep groove ball bearing, as it can carry mainly radial load with some light axial load. And due to this outer ring design, this bearing can handle small amounts of misalignment. The next bearing is a double row angular contact ball bearing. This is a back-to-back set all packaged into a single bearing. The last one is a 4-point contact ball bearing. In this style of bearing, the inner ring is split, as you can see, and the curvatures on this outer ring are changed so it actually has 4 contact points. So it is also designed like a back-to-back bearing in an envelope of a single bearing. Terminology. I know while I was discussing the ball bearing section, I used some terminology that you might not be familiar with. So we will take the next few slides and hopefully answer some of those questions you might have on the back of your mind. The first part of terminology I want to discuss is load condition. I mention load all the time in discussing types of bearings. There are various kinds of load conditions. Knowing the type of load condition will help us picture or imagine how the bearing is supporting this load, and this will help us in the selection process to ensure that we are giving you the proper bearing for your application. There are 3 major kinds of load that we discuss often. The first one will be radial load, the second will be axial load, and the third will be moment load. Our first type of load that we're going to discuss is radial load. A radial load is at a 90-degree angle from the shaft, as seen by this image. This particular load is impacting the housing and being carried by the upper rolling elements of your bearing. In my picture here, I am only showing a single bearing carrying load that is slightly inaccurate. Based on your internal clearance, multiple rolling elements can actually carry this load. It is also important to know, as we'll see, that this load can also be affected by the inner ring, which will be our next slide. The other type of radial loading can actually be carried by the shaft. So if the load is being carried by the shaft, the load will be pushing to the bottom rolling elements. As you can see in this image, similar as the top one, not a single rolling element is going to be carrying this load. It will be multiples depending on your internal clearance. But the important fact is that how the load is being applied dramatically affects how the bearing is carrying the load. Our next major load is axial load, commonly referred to as thrust load. This load can also be carried by either the inner ring or the outer ring, as displayed by my arrows. This arrow is showing that a load is passing through the shaft, and these 2 arrows are showing that a load is passing through the housing. In both cases, This load will force the rolling elements to go up the shoulder further by offsetting the two rings. And when this scenario occurs, every single rolling element carries a part of that load. Our next major type of load is moment load. Moment load can often be referred to as an overhung load. This can be from having a large sheave on the end of your shaft or a big fan. What you do is this heavy load out here pushing down is trying to twist that shaft, causing a twist on the inner ring of the bearing. You can also see a load out in this area in the housing or even further out here, causing the housing to want to twist. So it'd be the outer ring wanting to rotate on that bearing or twist the bearing. When this occurs, because the rings are being tipped or rotated, you'll actually have a contact area inside the bearing on both the upper and the lower rolling elements. And that is called a moment load. There are other load conditions out there, such as shock and vibration. Shock and vibration are difficult to predict, difficult to measure, but it's very important for us to note that they are present. By knowing that you have a shock or vibration, it might change you from using a ball bearing to a roller bearing. So it's very important to note that they're there. The other thing that's very critical is all of these loads can be applied at the same time. So you can actually have an axial load and a radial load and a moment load at the same time. So again, it's important to try to identify all the loads that are occurring so we can best select the right bearing for your application. The next terminology item I'm going to discuss is types of rotation, or rotational speed, often referred to as the limiting speed or the reference speed. Every bearing catalog can spell out or use different words. So really the important thing that we're looking for is the highest speed a bearing can continuously operate without generating critical heat or reaching thermal runaway. There's different terms out there and they mean different things. One is based on the mechanical limits of the components on the bearing. If you've ever been in a shop, now I don't recommend this, where somebody had taken a bearing and hit it with pressurized air to cause the bearing to spin at a high speed, and that bearing can physically disassemble or explode in your hand. That is reaching the mechanical limits of the components, where the other speed is where it gets to the point where it can't maintain temperature and reaches this thermal runaway. And that's what we commonly are looking for when people use the term limiting speed. The other part that is important with rotation, a lot of times when we're given a bearing life calculation, somebody will just tell us, hey, the bearing's going 1200 RPMs, and that's all they tell us. A simple RPM constant is fine if that's what the bearing is truly doing. In a lot of applications, that speed is intermittent. It might be start and stop, and that matters on how the bearing performs. Other things that can occur, it can be that same 1200 RPMs either going forward or going backwards. So one direction or both directions is important to know also. The last one is oscillation, to where the bearing might not even rotate 360 degrees, but that moving back and forth is very critical for the application engineer to know. The last thing is which ring is spinning, the inner ring or the outer ring. Because if it is the outer ring, in most terms, that outer ring, when it rotates, and that's what you're measuring, the rolling elements are moving faster. So it's very important for us to know which ring is doing the rotation. This next slide is really not terminology, but I like it anyway because it does give us a lot of transition from our ball to our roller bearing. So Why do you use a ball over a roller bearing? So if I'm simply supporting a single load or a 1-point load, that's this guy standing on a ball. If I have to support multiple guys, putting them on a ball is very difficult. So I might put them on a beam. Now granted, that picture, the beam might be a little more scary to me than standing on the ball. But regardless, it's kind of a way for you to think about the single point contact versus the across a line contact. The next slide will be the more common one that you're used to seeing. Now here's your more common point contact and your line contact. The very basic stress calculation is force over area. And that area is the contact point between the rolling element and the raceway. So on a ball bearing, you have a ball. So you truly have a single point contacting the raceway. So that area is very small. Under compression, it turns into this contact ellipse, but again, that area is extremely small. To where you look at a line contact, you have the contact point across the length of that roller, so your area is much larger. So force divided by a larger area will reduce your stress. That is one of the main reasons that you use a roller bearing over a ball bearing. Now that we've discussed bearing terminology, it's a good time to go back into the bearings. Now we will discuss roller bearings, commonly found in electric motor repair and pump repair. The first type of roller bearing we're going to discuss is the cylindrical roller bearing, called cylindrical because the roller is in a cylindrical shape. It has the same four components as your ball bearings do. It is composed of an outer ring, a rolling element, which is a roller in this case, a cage, retainer, or separator, and an inner ring. Similar to the other bearings, the contact area between the rolling element and the rings is called the raceway. This design of bearing with the roller, because it has that large contact area, that line contact, is designed to take on very heavy or heavy radial load. These bearings do come with different shoulder designs for placement and support within the application. The different ring designs on the cylindrical roller bearing allow for this bearing to slide or have the rings move so the bearing can handle the heat or the thermal expansion. On the NU design, you will see that there's no shoulders on this inner ring. So if heat is generated, this ring has the ability to slightly move back and forth to allow for that thermal growth. On the NJ type, you have a shoulder on one side, so its growth can only go in one direction. Similar to the NU is the N, where in this case the shoulders are going on the outer ring. So this outer ring can move in both directions. Similar to the NJ, the NF has a shoulder on one side, so it can only grow in a singular direction. The NUP design has a washer on this side that's actually locking this roller into a solid position, so it really is not designed to move in the application. Few other types that are out there are the double row, 4-row, and shaker designs. Our next major bearing is the tapered roller bearing. The tapered roller bearing's components are similar to the other bearings, but their names are slightly different. The outer ring is commonly referred to as the cup. The inner ring assembly is commonly referred to as the cone. Within that assembly, you have your inner ring, your rolling elements, and your retainer cage or separator. Tapered roller bearings are designed for both heavy radial and axial loads. Tapered roller bearings also require an amount of preload to keep the rings in position in their application. Similar to our angular contacts, the tapered roller bearings can be ran as sets. The same terminology is used for two bearings running in the same direction. They're called tandem, and this allows for having a higher amount of load than a single bearing. Because the design of a tapered roller bearing is a little different, you can have a thing called cage stick out, and the rings might be offset slightly. You must employ spacers on the inner and outer ring on certain arrangements. On the back-to-back, it's similar. As the contact angles go away from each other, it builds a more rigid design. And if they are in the face-to-face design, the contact angles are converging or coming into each other and allows for some slight misalignment. Our next major roller bearing is a spherical roller bearing. This bearing has the components of an outer ring, rolling elements, retainer cage or separator, and an inner ring. On this style bearing, there can be many different designs of the cage. The cage is shown as a split design. There's also one-piece designs. There are many materials that this cage can be made of, such as steel, polyamide, and bronze, as shown in this picture. This bearing can also come with an oil groove and oil holes in the outer ring surface. This bearing also has other special designs where they are made specifically for shaker applications. This bearing is designed mainly for heavy radial loads and some axial load, with the capability of some slight misalignment due to the curved surface of the outer ring. There are many other types of roller bearings. We have a spherical thrust roller bearing, sometimes referred to as a 29,000 series bearing. This bearing is very common in vertical pumps where the load has become so heavy that we cannot stack enough angular contacts on top of itself. There's the pure or thrust roller bearing, which, similar to the ball bearing thrust, is the rings are considered washers with the rolling elements and cage riding in between the two washers. There are needle bearing designs, and there are cross roller and many more. Now that we've completed our discussion on ball bearings, roller bearings, and terminology with our focus on electric motor repair and pump repair, we'll do a quick wrap up and contact information. If you'd like to learn more about bearings, please visit www.midpointbearing.com. There's a tab on there called Bud's Take, which is a section where I write articles that discuss a whole bunch of different bearing ideas, from basic to some more complex. The presentation that you just sat through, most of it is covered in issue 24 and 25 in the Bud Takes section. Also, if you have any questions or comments, feel free to directly reach out to me at my email, bud@midpointbearing.com. I'd also like to give a special thanks to all of our bearing suppliers for supplying images and data for me to put this presentation together. I'd like to say thank you one more time, and again, feel free to reach out via midpointbearing.com or email me at bud@midpointbearing.com and give me some feedback. Let me know what else you'd like to hear about. Thank you again, and have a great day.